Currently, scientists have little doubt that life on our planet originated in water. This is supported not only by theoretical research but also by archaeological findings. In this video, we will present undeniable examples of this evidence and explain why many living beings chose to leave the ocean and begin colonizing the inhospitable land. Water is fundamental to the existence of all life on Earth. The embryos of many animals begin their development in aquatic environments. A fully aquatic lifestyle allows ocean dwellers to grow to truly gigantic sizes. Most land animals are excellent swimmers, and many, including humans, enjoy spending time in water. So, what compelled the distant ancestors of today's terrestrial creatures to leave the welcoming waters behind? At the end of the Ediacaran geological period, which concluded around 540 million years ago, all life was confined to the oceans. The most advanced creatures were worm-like or flat disc-shaped bottom dwellers that fed on floating nutrient particles. Scientists believe that these beings lacked not only skeletons but even muscles, as such adaptations were unnecessary for their way of life. However, by the end of this period, some animals began to adopt an active hunting strategy, preying on defenseless inhabitants of the ocean floor. These soft-bodied creatures had no means to defend themselves against this new threat, but it was this very threat that pushed them toward evolutionary change, developing defensive adaptations and various escape strategies. One such strategy was to transition into a new environment where there were no threats from other animals. However, simply leaving the water and starting life on land was not feasible. The land was not ready to welcome new inhabitants. The land at that time was barren and lifeless. Its surface was covered with icy wastelands, volcanic regions, and sandy or rocky deserts. The oxygen content in the atmosphere was so low that no modern creature could survive there for even a few minutes. The next geological period, the Cambrian, marked an explosive development in evolution. In the deposits from that time, scientists find a vast number of fossils of animals with prominent external calcium skeletons. This indicates the presence of armor that marine creatures developed for protection against predators. Additionally, during the mid-Cambrian period, small animals known as hyoliths developed an internal cartilaginous tube running along their bodies, which became the precursor to the backbone and led to the emergence of vertebrates. Small creatures resembling flatworms, called hallucigenia, also developed their first muscles. It was the emergence of the first predators that set evolution on a path ultimately leading to life's transition onto land. In addition to developing armor and increasing speed, living beings sought habitats where predators could not reach them. One such natural zone was the shallow coastal waters and tidal areas. An abundance of sunlight and warm water allowed the first primitive algae and microorganisms to thrive along the shores of seas and ocean bays. Gradually, due to the ebb and flow of tides, colonies of these living organisms began to emerge on land. When examining deposits dating back around 530 million years, researchers discovered not only a wealth of remains from various aquatic creatures, but also the beginnings of soil formation in coastal areas. The first plants and microorganisms that surfaced started to decompose, creating more favorable conditions for their successors. It is likely that the initial thin layer of soil gave rise to colonies of fungi, which processed plant remains to extract nutrients. Over the course of the next 100 million years, vast stretches of land became covered with the first lichens, resulting from the symbiosis of these fungi with microorganisms. During the subsequent Ordovician geological period, the first multicellular plants fully adapted to life on land appeared on Earth. Meanwhile, the arms race between predators and their prey continued in the waters of the oceans. By the end of the Cambrian period, a diverse array of arthropods moved along the ocean floors on jointed legs. Among them, eurypterids dominated, with some reaching sizes of over 2 meters. Their jointed appendages became one of the adaptations that later helped animals transition onto land. However, a complete exit from the aquatic realm was still a long way off. Following the Ordovician Silurian extinction event, which wiped out about half of all living beings on the planet, arthropods became some of the most prevalent creatures in the underwater world. Yet, the seas of the early Silurian period were teeming with predatory fish, giant eurypterids, and other dangerous beings. As a result, many arthropod species increasingly ventured out of the water onto land. The shores of seas and oceans provided them with abundant plant food and safe shelter from predators. Their chitinous exoskeletons offered protection from sunlight and helped retain moisture. However, these creatures could not leave the aquatic environment for extended periods. Their respiratory organs needed to remain constantly moist to function properly. Nonetheless, these pioneers became the ancestors of all modern insects, spiders, and crustaceans. The definitive transition of animals to a fully terrestrial life occurred during the Devonian period. At this time, the planet's surface was no longer dominated by primitive lichens, but by the first vascular plants known as rhiniophytes. These plants became the ancestors of ferns, mosses, and horsetails. They thrived along the shores of marine bays and in river deltas. Rhiniophytes lacked a true root system and were often washed away by rain, taking the top layers of soil with them into nearby bodies of water, which turned them into true swamps. These marshy areas, rich in organic matter, became home to a vast number of insects. Following the emergence of plants, fish also made their way onto land. However, breathing solely through gills in a swamp is quite challenging, so gradually fish learned to inhale air from the surface and developed lung sacs. One such fish was the Eusthenopteron. To navigate through the densely vegetated waters, their fins evolved into longer appendages with additional bones and strong muscles. With these pseudopods, the fish could move from one drying puddle to another. A similar mode of movement is still seen in some modern fish, such as mudskippers. Creatures with lung sacs and elongated fins were already closer to modern amphibians than to fish. One of the earliest transitional forms was Acanthostega, an amphibian that lived in what is now Greenland. This creature had 4 almost fully developed limbs and a lung sac, yet it still possessed fish-like scales and gills. Another transitional form between fish and amphibians was the lobe-finned fish Tiktaalik, which inhabited the swamps of present-day Canada. This fish breathed through both gills and lungs and could move on land by propping itself up on its powerful fins. Tiktaalik could hear equally well in water and on land, indicating that it spent roughly equal time in both environments. By the subsequent Carboniferous period, amphibians had completely bid farewell to their aquatic habitat. Evolution had forever separated the inhabitants of the seas from those of the continents. Further transitions of living beings from one environment to another became more of an exception than the rule. The new habitat was no longer a safe haven. Terrestrial predators quickly dealt with aquatic animals, while land-dwelling creatures found it uncomfortable in the water. Perhaps the only positive example of such a transition is the emergence of cetaceans and pinnipeds. Their ancestors decided to conquer the aquatic realm once again and succeeded in doing so. It's possible that evolution is now on the brink of conquering yet another environment, outer space. This process is just beginning, and the full settlement of Earth's inhabitants across various corners of the universe will also require millions of years of development. One can hope that this new living space will gradually cease to be hostile to us, just as solid ground once became a new home for the inhabitants of the ocean depths. We thank viewers who watched this video to the end. On our channel, you can find a wealth of information not only about the age of dinosaurs, but also about other periods of life on Earth.